In the previous episode, we managed to mate the transmission and engine together and bolt the engine up to the frame using the Summit Racing engine mount kit for the S10. We also rough cut and re-welded the transmission crossmember bracket with the new transmission and existing crossmember in place. And finally, we attempted to start the engine using a Demon carburetor, but were unsuccessful in doing so, at least for more than a couple seconds. So in this episode, we will first address the starting issues, and then move on to installing the EFI system, along with the supporting wiring and fuel lines. I will also show the process that we went through to weld up the crossmember using the rough cut and re-weld that we did in the last episode. As a fuel source, we'll back the Tahoe up to the S10 so we can siphon fuel out using our bucket, fuel pump, and filter setup.
Clear. There you go. It was clear.
No, it's not.
Hold on.
Alright, I'm going to drain the filter. Hold on.
There you go.
Since the truck has been sitting for a few weeks, we figured that the carburetor would be empty and the engine would not be flooded, which should give us a better chance of getting the engine to fire up, at least momentarily. And after a few attempts, it seems that the timing might be off, but also that the air-fuel mixture was way off, as choking the carburetor seems to allow it to run for more than 1 or 2 seconds. And while it isn't running perfect, we at least know that it is something related to the air-fuel ratio, the timing, or both, and not a catastrophic issue with the engine block, crank, pistons, or something of that nature.
I think the timing is...
As mentioned in previous episodes, we are going to be installing FiTech on this S10, and the reason I picked FiTech over the competition is simply because all the tuning can be done with the included touchscreen. And while there are similar products on the market now, FiTech was arguably the first to do it, at least that I have heard of with a reputable brand name. This system will also intelligently learn what air-fuel ratios to use as you drive the car in different conditions. It's also worth noting that I worked behind the scenes on the TV show Junkyard Empire and actually set one of these up before, so I already know what to expect from the setup process, and I know that it is a dependable product, even if it has tuning and technical limitations that might limit its maximum potential to generate horsepower compared to other products in this category. First, we'll install the FiTech unit itself, which bolts up to the engine just like a regular 4-barrel carburetor. With the FiTech unit secured in place, we can measure out how much high-pressure fuel line we will need between the FiTech unit and the existing steel fuel lines on the S10 frame rail. FiTech allows you to set up the fuel return line a couple different ways. In this instance, since the S10 has a return line, we are also going to install a high-pressure fuel return line. If your setup does not have or does not allow for a return line to easily be implemented, you can set up the FiTech system in what's called a deadhead configuration, where the fuel entering the carburetor has no way of returning to the tank. There are several advantages to using a fuel return line over deadheading. But the most notable or important reason is that your fuel system will have a constant supply of cool fuel from the tank, whereas a deadhead system will allow for a quicker and cleaner install at the cost of potentially vapor locking your engine due to heat soak. Now, it is also worth noting that the system that GM used in 1988 on these trucks did not use any kind of threaded fuel fittings. Everything is hard or soft lines using hose clamps or fuel line clamps to transition between the two. This poses a unique challenge since the FiTech system uses AN style fittings, so I spent about a week trying to find the cheapest combination of high pressure rated soft line, an inline fuel filter, and AN fittings to connect the soft line to the FiTech system. And it still all came out to about $150. If there was no budget constraints on this project, the solution would be to run AN fittings from the fuel tank all the way up to the FiTech unit. But this would require replacement of the sender assembly or the replacement of the entire fuel tank with a fuel cell. While I work on the fuel system, Mike is working on the Crossmember, and there's not much to do to it, but it is important that all of the welds are thorough, so what he is doing here is adding additional metal to add structure to the cut and re-weld that we did in the previous episode. Once all of the welding is complete and has been double checked, it will be thoroughly degreased, washed, and painted with a high quality paint. Mike had a few different color engine paints left over from previous projects, so I decided on Chevy Orange since it would give a little bit of flare underneath and it would make the reinstallation a little bit easier since it would be a lot more visible in the dark underneath the vehicle. Once the paint dries, it can be reinstalled in the reverse order it was removed, and the transmission securely attached to the new bracket. Now we'll move on to the electrical system, and there are some continuity errors since some of the wiring was done after the cooling system and fenders were reinstalled, and I'll be sure to make an episode on the cooling system in the future. As with the fuel system configuration, the FiTech also supports several different wiring configurations depending on what kind of distributor or cooling system you are running. Now, I'm away from the truck right now, but from memory, I'm going to go through all the different wires that connect to this system and explain a few of the different configurations that you can go with. As with all ECUs or PCMs, this system has a constant 12 volt in for memory and key off touchscreen use, as well as 12 volt in from the ignition switch. This connection will cut fuel when you turn the key off, as well as cut off the ignition in certain configurations. As mentioned in previous episodes, this build is using an HEI distributor, which is completely self-sufficient. All you have to do is supply 12 volt power and the correct timing, and the distributor will do the rest of the work. This style distributor also has a tach output, which would traditionally feed a tachometer gauge. However, the FiTech will use this as a reference to know the engine RPM at any given time and use that in conjunction with several other variables to determine how much fuel to supply to the engine. In other configurations, the FiTech can actually phase the timing and act as not only the spark trigger, but would also be your tach output. And as cool as it would be to be able to adjust the timing on the fly through the touchscreen, this distributor is not compatible with this configuration. FiTech can also be interfaced with MSD products, but as you can see in this setup, it isn't required. Another signal input that the FiTech uses is the water temperature, and it actually ships with its own temperature sender and harness, so the sender is actually plug and play, no wiring is required. The temperature sender obviously provides temperature data, which can be used to determine if the engine is at operating temperature or not, as well as to signal optional electronically controlled cooling fans. Also plug and play is a standard Bosch style oxygen sensor, which can be mounted on either exhaust bank and helps determine the air-fuel ratios that should be used as the engine is running. The FiTech can also internally determine altitude via a barometer, and it also has an ambient air temperature sensor. These are internal and obviously do not need to be wired up. In addition to signal inputs, the FiTech also has signal outputs. One of those outputs is to the fuel pump, and depending on the setup, this output can actually use PWM to control the pump flow. But it is my understanding in this setup it is simply in an on or off state, and the fuel pressure is regulated at the fuel rail with the built-in fuel pressure regulator. Another output that is being used is the cooling fan trigger wire. And if your setup uses a mechanical fan or is somehow air-cooled, you do not need to use this feature. But this wire would go to a relay which would turn your electric fans on or off. I didn't really take any close-up footage of each of these individual wires being connected, but as you can see from this time-lapse, a lot of those connections were made from the original vehicle wiring harness, and the rest are between the distributor and FiTech and a newly installed auxiliary relay and fuse box. By the time the FiTech unit was wired up, the year 2020 had kicked into 12th gear, and the truck sat for several months, where I would come to work on it by myself in my spare time, which mostly consisted of trial and error, ordering different cooling system parts, and putting the front fenders back on. And that brings us to this point here, where the FiTech system and cooling system are wired up in a way that will allow us to test fire the system for the first time. And as you can see, the FiTech system has figured out how to maintain an idle. However, it doesn't appear to be hitting its 800 RPM idle target that I had set in the settings. It was also very quick to die, similar to when it was running on a carburetor.
Yeah, see, as soon as you get on the throttle,
After some troubleshooting, we determined that the timing was actually way off, and after completely resetting the distributor, we were able to get a much better idle.
Yeah.
And it's probably to be expected, but this engine now sounds a lot more like the engine out of a 1999 Suburban. And that's because it is, for those of you tuning in now.
That's a lot of liquid. No, nothing.
This is the first sustained run with coolant present, so this is also a good time to check for leaks. After letting the engine get up to near operating temperature, it's still running at a nice 800 or so RPM, and while I could probably push this a little bit closer to 700 or 600 RPM even, I really want to let the engine run a little higher so that it has good oil pressure, since this is the first time this engine has actually run in almost 4 years. Sure, we've been test firing it here and there, but those have really only been for a few seconds at a time. This is the first time this engine has really run, and it's quite a sight to see. The last time this engine was turned on and sustained idle, it drove someone to their final moments on Earth. With all of the computer-related wiring connected, we can move on to the charging system and battery wiring. For this build, I have decided to mount the battery somewhere in the back, and my mind completely deceived me on how thick 4-gauge wire actually is not, so I ended up ordering a lot of battery cable in different sizes. Since the battery is going to be at the back of the vehicle, integration of the alternator wiring and factory wiring harness get really interesting. To illustrate, I have devised this beautiful diagram in MS Paint. And this certainly isn't the only way and might not be the best way of doing it, but this is the way I have done it and it works. In short, no pun intended, power leaves the battery, goes through the safety shutoff switch, and to the starter. From the same terminal of the starter that the switch and battery is connected to, a second wire runs to a power distribution block, which connects the alternator and the wiring harness to the 12-volt in from the battery and starter. The battery is connected straight to the starter to allow as much current as possible to travel the shortest amount of distance, since the starter, at least on this vehicle, is the most amp-hungry electronic on board. The rest of the vehicle draws significantly less amperage, which means cables can be longer and smaller. If the starter cable was too long or too small, the wire will just act like a glorified resistor and get really hot and potentially catch on fire or cause the starter motor to overheat from not being able to operate efficiently. And before you comment, yes, there will be fuses in line throughout the circuit. It was just too much to put on this diagram. First, we'll mount the power distribution block. We'll install this near the auxiliary fuse box, which will also connect into parts of that main wiring harness, making it easier to connect all the connections without spreading the harness too thin. The location of this auxiliary fuse box and this distribution block is also near the factory battery location, which should allow the length of the factory harness to remain relatively unmodified. On small block Chevys, the starter motor is also on this side of the vehicle, which also makes that easier to bridge into the battery wiring. In order to connect accessories like the alternator and starter, we will need to crimp lugs onto the cables. And this is very similar to how you would crimp on a spade connector, just on a lot larger scale. So we'll use this special tool, which you smack with a hammer, to crush the lug down onto the cable. The end result is an incredibly solid bond that is very hard to pull apart. We'll install our first 4-gauge wire between the alternator and distribution block. Next, we'll tie in our factory wiring harness, which ultimately ties into the fuse box and powers things like the radio, headlights, and the FiTech system, which is spliced into the harness where the factory computer was. Some of the accessories in the auxiliary fuse box will also be connected to this terminal on the distribution block. Next, we'll determine the most ideal place to mount the battery. In the past, I actually secured this ammo crate to the truck bed, so I'm going to attempt to use it as a battery box. And after test fitting a couple different batteries and taking some measurements of other batteries, we can conclude that this box will work just fine and fit most battery groups. So we'll drill a couple holes, one for the positive cable, one for the negative cable. These cables will be gauge 2 wire, so the holes will need to be large enough to accommodate them. With the positive cable routed to the makeshift battery box, we'll run the other end to the starter. And from the starter, we'll run another cable up to that distribution block. This is also a gauge 2 cable. After running all the positive lines, we'll run a ground cable from the chassis up to the battery box. This cable will be attached directly to the frame rail to ensure that the battery and electrical system stay grounded to each other. And with a lot more to be done on the battery box itself, as well as implementing fuses, I think I'm going to end the episode here. I really want to go into detail on the battery box itself, and it will just take too long in this episode. Plus, quite frankly, I've run out of video footage and need to film the rest. So we'll catch you in the next episode.